face down on the mattress one, and you hold me, and we are broken. Still it's something I wanna do just a little. Now feel myself heavy off the ground. I'm scared I'm not coming down. No, no. And I won't run for my life. She's got the toss down, locked down in a smile, but nothing is alright, alright. And I want something else.
Oh, sorry, it's time. Talk about it afterwards. All right. I guess it's time we get started. So good afternoon, everybody. We're going to be doing some technical stuff now and talk about the new framework, the killer feature that we are introducing with Odoo 13. That feature is actually the baby of Fabien Pincars, our founder and CEO. He couldn't join us today, so I'm going to be presenting these concepts to you. That's why his name is on the slides. These are his slides. And doubly so because he's been relentlessly working to introduce these changes in the framework of Odoo. This is really a big step. We call it like the biggest refactoring since version 8. Because if you were around during the evolution from version 7 to version 8, there was the introduction of the new API. It was a kind of a revolution for programmers of Odoo features because it made the life of developers a lot easier by introducing higher level abstractions for programming Odoo business code. It made a lot of difference having to write less code for procedural code for connecting things, boilerplate code that were now taken care of by the framework. But it came with a big change of programming API, and that meant a lot of modules had to be rewritten to work with the new API and to have the benefits of these new features. It came with the introduction, it introduced the depends decorator that was making a lot of magic for computed fields. And this version with Odoo 13 introduces a lot of difference in the implementation in the internals of the ORM. And it comes with almost no change to the API. So it's a good news. There will be no need to rewrite all the features of the business modules. And every app will automatically benefit from the new features. And the best aspect of that is, of course, performance. Performance is the key feature that we were working on with this refactoring of the ORM. Anthony has shown during the keynote this morning that we have measured improvements of up to 4 or 5 times on the times it takes to perform most of the typical transactions that you do in a business app generally. So there are here the numbers in blue for Odoo 12, for reading a certain number of records in the database, for creating, for updating. And you see the times in red. The bar, of course, is a lot better with Odoo 13, and you can see the ratio between the two. There's one in the middle that is a little bit impressive, is for confirming an invoice. And that's not because the framework doesn't do a good job, it's because the system of confirming invoices has changed in version 13, and it creates the journal entries early on in the process. So that's why the difference is less striking. This is in terms of the time it takes to process a transaction with a certain number of records. But there is also a big improvement in the number of SQL queries that are executed by these transactions behind the scene. And the numbers here are shown in a relative chart, where you can see again in blue the number of queries, actually the relative number of queries that it was necessary in Odoo 12 for these business transactions compared to what we have now in Odoo 13. And you can see that there's a really big difference there. So this is benchmarks that have been run on a normal demonstration database, so there's not a lot of records. So it translates into an improvement of the speed, and the kind of gain that we can have from this reduction in the number of queries is going to be even more impressive with the number of records growing up to large volumes. You may be surprised to see that on the left side we have one bar that is just cut in half, so the number of queries were the same in Odoo 12 and Odoo 13. And that is actually easy to explain. It's the simple read access to a lot of records, and Odoo 12 was already doing a good job at that. But if the numbers here are similar, in the previous graph, the numbers on the left, you see that it is still a lot faster in version 13, because it's not just the number of queries that has been reduced, but also the processing that is required in memory after retrieving the data. So let's have a look at the changes that were necessary to get those benefits. The first one is the unification of the cache system. You may be familiar with the way a request is associated with a cache in Odoo, so a transaction that comes to the server is handled within an environment that has a user and some contextual information. And in Odoo 12, you see on the right, there is a sample of code where you see a sequence of operations. First, we are accessing a field, self.field. This causes a query in the database to retrieve the value of the field. There's no way to optimize that. Then the next line introduces a new environment by changing some attribute in the context. This actually creates another cache for version 12. And this means that the next access on the third line is going to cause an extra query to the database to fill that new cache. So that's an extra access to the database that we are now saving in Odoo 13 because we are trying to reuse the same cache. And it does make sense because if you think about it, the values of fields in the database, there's only one value for each field. So there's no need for having different caches for different environments in most cases. There are cases where it matters when fields are computed depending on values in the context. And for these cases, Odoo 13 introduces a small difference in the API. You can see on the left at the bottom that there's a new decorator that was introduced, depends context, and that is specifically dedicated to indicating fields that will depend on the context value. And these will be stored in a slightly different part of the cache with a different structure. But the real good news is that everything else in the cache is going to be shared between the different environments. So all on version 13, you can see on the right that all the different accesses within different environments will not cause extra queries to the database. And that's faster, but also less data to post-process after retrieving it from the database. The next thing that was a big deal changer in the new ORM is trying to work more in memory, storing values in the cache rather than directly writing it to the database. In Odoo 12, if you look at the example on the right, whenever you are changing a value of a field, immediately we push that change to the database so that we synchronize as much as possible the state within the request and within the database transaction. But this causes some inefficiencies because we may be within the same transaction modifying several fields on the same object, or even the same value is going to be updated a lot of times. For instance, if you are computing some values in a sales order and there are changes on all the lines, every single change to each line is going to cause some changes to be recomputed on the order itself, like the total amount. But there's no need to push every single time that small change to the database. We can just try to put it in the cache and wait for some later time where it's the point where we want to flush those changes to the database. And by doing that, we save a lot of extra work and extra queries. For this reason, version 13 introduces the flushing mechanism where the developer has the power to decide, oh, now it's time when I want to flush all the changes into the database. One of the reasons you may want to do that is because you are going to execute manual SQL queries in the database, and those depend on the latest values for the field. So you want to push everything directly in the database. But most of the time, you won't want to do flushing yourself, and the ORM is going to do the work for you. For instance, if you call the search method that is going to query the database is going to flush automatically everything that is targeted by your criterions on the search, because it's going to analyze what you're searching for and make sure that everything that is relevant has already been flushed to the database. And we can see also that create is automatically flushed because there is no value in saving that, and it's easier for invalidating and connecting the different records. Dependencies are also computed in memory as much as possible. It wasn't the case before. Let's say you have two relationships that are opposite to each other, like a many-to-one and a one-to-many, connecting lines to their container object. Before, in Odoo 12 and the previous versions, whenever you wanted to know the number of lines in the container, like sale orders line, you needed to query the database to make sure that you were retrieving all of them. And sometimes, depending on the visibility rules, based on the active flag, archived records, the number of results in those one-to-many values could be different. But that meant a lot of select, repetitive queries sent to the database to always know what are the lines for an order. So now in version 13, we try to always prefetch and keep those one-to-many values in the cache, and always take the information from there. And that means that we are maintaining the cache also synchronously, so that we can always use the cache as the reference for the lines contained in the one-to-many. Also, because of this little difference with the active flag, the cache actually stores all the records, even those that are inactive, and just filters them out when you access the value of the one-to-many. So that's also a good enabler for performance there. Computed fields. There's a lot of work that is done by the ORM for maintaining the values of computed fields. That's the magic that happens because of this decorator, depends, where you can tie the recomputation of a field to all the dependencies that need to trigger it. This is a big cost if you recompute a little bit too frequently. And version 13 tries to delay those recomputations as much as possible. We were talking previously about this sales order container with lots of lines, and whenever you modify a field of one line, you are going to trigger like a cascade of changes in the line itself, like recomputing the subtotal of the line, but then also on the container object to recompute the total amount of that order. But if you are in a loop changing all the values on all the lines, there's no point recomputing the value on the order itself 20,000 times. You can just wait until you're finished and then compute it. So instead of recomputing field values, as soon as one of the dependencies is changed, in version 13, we try to wait. We just remember that the value is not correct anymore. It needs to be invalidated. And we are only going to recompute the value when there is a moment where we need to read the value, or if there is no point where we read the value, when the transaction is about to complete and it's time to flush everything back into the database. And you see the example on the right, where the loop on Odoo 12 would be for every instruction, like we're changing the quantity of the product, the discount, the price, and we do that in a loop. And every single time for every assignation, we are going to recompute a lot of fields on different objects. And in Odoo 13, at every assignation, we're just remembering that we need to invalidate the dependencies, but we are only going to really recompute them when we access the value or when we flush. That's a very important optimization. And because we are delaying this recomputation, we are also trying to delay all the changes that we need to flush to the database. Basically, we are keeping a buffer, a queue of all the changes that still need to be flushed to the database. That's the to-write queue. And we are going to optimize this flushing to the database because maybe we are updating several fields on the same record. So instead of doing that one field at a time, we are going to do a single update with all the field values. And if maybe we are working on a batch of records, we are going to update the field values of several records at the same time, saving us a lot of extra queries that would cost us time and round trips to the database. There's another optimization that is a bit more technical, is the way one-to-many fields and many-to-one reverse relationships kind of cancel each other in some cases. If we are still looking at the same example with a sales order and other lines, whenever we modify something on the order, let's have a look at this example here on the screen. It's kind of a weird case where we have a global discount on the object, the order object, and the line have a subtotal that depends on the price on the line and on the discount that is globally set on the order. This means that whenever we modify the discount, we are going to have to modify all the subtotals of all the lines. But, and this is not displayed in the example, there is also a total amount on the order. So this means that we are going also to have to invalidate the total amount on the order once we have followed the whole cascade of dependencies. And if we do that for every single line, we start with the discount on the order, and then for every single line, we are going to jump back to the total of the order and invalidate it once. And for the next line, we do it again and again and again. So that's a lot of repeating and redundant invalidations. So version 13 of the framework will optimize out these things and directly bind the invalidation of the total amount on the order, because it knows that jumping to the lines and back to their container is a no-op operation, saving a lot of extra computations in the memory. There is another optimization that was done by doing micro benchmarks of very massive operations on reading and populating the cache with a lot of records from the database. And by running this micro benchmark, we noticed that we were losing a lot of time converting again and again the data that is retrieved from the database into different data structures until they were actually returned to the caller of the read function. So you can see on the screen on the right the structures. When the data comes from the database, it has to be put in cache, converted, then converted to the result of the read format, and again and again. And doing that was actually costing a lot of time. And this optimization that we did, you can see on the bottom right the Odoo 13 version, where there are a lot less different data structures, and we try to keep as much as possible the same structure that is directly returned by the database accessor. We save a lot of time, and that's why the number of queries for reading a lot of records is not lower in version 13 if we're just reading, but the time to do that is a lot less, and we are achieving a large benefit just because we are doing a lot less conversions in memory. We did the same kind of micro benchmark on different areas of the ORM, so that gave us also quite a lot of smaller benefits left and right, and everything adds up to give this very impressive boost of performance that we see with the version 13 of the ORM. And we are also introducing something that we have been looking at for quite a few years, a way to deprecate these on changes. If you're familiar with the Odoo API, on-change is a mechanism that was introduced way before version 8. It was always there, and it was a way to trigger a recomputation in the screen. But it's not very elegant. It doesn't really make for modular code. It is kind of very hard to track down, and it has a lot of drawbacks, the way on-change works. And it's a bit, it's even completely redundant with the way computed fields work. Computed fields are basically formulas, like Excel formulas, where you define the result of the computation that you want to get. But on-change is like reversing the logic. Let's see. Who can tell what does on-change partner ID do on a sales order? So, of course, the name says it. It's what happens when you change the partner ID, the customer, on a sales order. But what other fields is it going to impact? You don't know. It depends on what are the modules that are installed. It's going to be very hard to track down. On the other hand, if you look at, OK, how do you compute the price list on a sales order or the delivery address? Well, that's a much easier concept to grasp. It depends on the partner, for instance. The delivery address is going to be taken from the delivery address of the customer. So we're trying to get rid of all these on-change because they have a lot of drawbacks. They can't be tested. Computed fields are applied in any way you use the model is going to always apply the logic of the computed fields. The on-change is a mechanism that was designed specifically for the user interface of the client. So it doesn't work, and you have to manually use it in your tests if you want to be sure that it is actually being called. Here, there's a small example on the right where you see that if you have an on-change partner ID, you're going to have to write procedural code that is setting the price list ID and the delivery ID based on the partner. And if there are other modules that are modifying this logic, there's going to be a stack of a lot of changes, and it becomes difficult to predict what is going to be the result of that. Whereas in Odoo 13, we want to go more and use the computed fields everywhere. And there was a limitation in the framework that made it very hard. It's when you want to compute the value for a field based on some other fields, but you also want to let the user change the value of the field. You know, with the computed field, normally the value is fully driven by the dependencies. You cannot just assign a value. So in Odoo 13, we are now making it possible to assign a value on the computed fields on top of having the value derived from the dependencies. The way to do that is to not assign a value in the computation method in some cases and assigning a value there. So you will define a computed field in the same way as in Odoo 12, but you could make it read-only false, and that means in the user interface you will be able to assign the value there. And the system will keep that value instead of recomputing. So kind of the computing method will be acting like a default unless you set a value yourself on this. There are lots of advantages, as I was saying, and we want to, in the future, go more in this direction. And maybe at some point we'll be able to completely deprecate this old on-changes method and switch to a more elegant model based on only computed fields. So there was a very fast introduction to these changes, these many changes in the new framework in version 13. Maybe you have questions about these? Let's hear that. Oh yeah, there's a mic there if you want to grab it. Oh, is it working?
Okay.
Yeah.
What about the inverse method and the search? Are we going to need to declare it? Or if we store manually a computed field, it's not necessary anymore?
Yes, exactly. You don't need an inverse method if you just set a value on a field that is now read-only false. It was like the old way of working with the inverse methods. And usually it meant that you were storing the value in different fields than the one that you were setting.
Okay, and we don't need inverse anymore? Or?
So not for these cases.
Okay.
If you're just making a computed field, a field that can also be assigned, then you don't need an inverse method for that case anymore.
Okay.
Okay.
Thanks for the talk. So how do you tell by the database whether the field has been manually overridden or not? It seems to me like we have it computed, but then we say that the user can override the value. Sometime you come back later, it'd be nice to know whether that was a manually overridden value or a computed one.
So your question is, how do we know if the user assigned the value or it was automatically computed by the computation method? Basically, the computation method is going to decide if it's one case that is allowed to be overridden by the user. So it's basically in your code that you will allow for one case where the computation method doesn't assign a value to the field, and in that case, you know that it was assigned by the user. So basically, you are still in control of this.
What I mean is, so we have record A, and the computed value is applied there. And then we have record B, and the user overrode that value. When I come back later and look at record B, can I tell that this was a computed value or an overridden one?
Not really.
And how does the framework know not to recompute that value later?
The framework does know, because the user will actually be sending an update to the field, and the recomputation will not be triggered because the other values will not, the other dependencies of that field will not override the value. It's like you have three cases in your computation method, like there's case A, B, and C. So if we change the dependencies, we are in case A or case B, but in the case C, we don't change them, and so we leave the value untouched, and that allows the user to manually change it. But still, the user is doing the change as a whole. It's not like the user is manually tricking the system into changing a value that's not allowed. If the user goes into a business case where the rule says, oh, we have to recompute it, the recomputation method will still do the job. So it's really like, maybe depending on the order in which you change the values, like, you know, on the sales order line, you will have a product, you will have a quantity, you will have a unit of measure, and depending on which of these things you change and in what order, one is maybe going to override the final value that is the final subtotal amount on the line. But you're still within the rules of the business if you do that. You see, the user will not be able to do anything that violates the business rules that you put in your method.
I think you answered my question. So if later, at some point in the future, recomputation is triggered, then that user-defined value will then disappear. Is that right?
Sorry, so if later any recomputation happens, it means that one of the dependencies of the fields has been changed. So there will be, as usual, tracking for this operation. And if the system changes the value, then the system will be the one recomputing and will be recorded as the source of the change.
Thank
really.
you.
Sure.
Hello, hi. One question about the cache. You mentioned like you just update in memory instead of SQL, right? So what's happening if other user try to access the same data? Is it go to the cache first, or is it go to the database directly?
The thing is, we are still working in a transactional model. So the cache only survives very shortly during a single request. So it's not like a global cache of the application. It's really just a very short-lived cache for the same computations and the same data access that is done by a single user within a single transaction. And it is by design that the other users cannot see it. So it's only shared through updates to the database, and only when the transaction completes successfully that everything is committed to the database. So this doesn't change with the new framework. Users' transactions are still completely isolated from each other until they are finished and committed to the database. And the cache doesn't change anything. It's just how the data is going to be retrieved and how often we retrieve data from the database or from the cache during the transaction.
Okay. So what you say is by design, so there is a small chance, that the data is inconsistent.
Oh no, it's by design in the sense that the only way for users to see the values that have been modified by other users is by reading from the database. There's no shared state that they can access outside of the database. And the database is implementing the MVCC model, so Postgres does that for us, so that transactions are fully isolated from each other. There's like snapshots that are taken at the beginning of every transaction, and users are kind of isolated in that snapshot of the database as it was when their transaction began, and they cannot see everything that is being done by other users until they commit the transaction, and then this becomes like a permanent change. So there's just no chance, it's impossible that they will see the effects of other transactions.
Okay. So basically, the cache is for read only in most cases.
Sorry?
The cache is for read only.
The cache is really part of the transaction, really. So it's in memory, but it's in the memory of the request when it enters the server, and then it disappears at the end of the request. It's part of the transaction, really. It's just like speeding up data access within that transaction. Okay. If you have other questions, or if you want to try it out, I suggest that you have a look at the log SQL mode, where you can start Odoo in debugging mode, so that there's a log level parameter to the server that you can use, and you can make debug_SQL, where it's going to output all the SQL queries that are sent to the database. And if you compare the output of that between Odoo 12 and Odoo 13 on different operations, you can use the Odoo shell mode, where you can simulate transactions and see immediately the effect, the number of queries that are sent, and that's going to give you a good idea of the changes that we introduced. Also, there is a technical workshop for developers currently in, I think, C5. You can also come join there and ask questions or try it out. You have one last question?
Hi, yeah. Now there is this mechanism in the ORM that it caches all values, and in the end it flushes and writes them to the database. So my question is, does it do anything like to batch SQL queries somehow automatically? For instance, if you were creating multiple records, and in create, if you would flush them, would it do one insert into statement for each record, or would it batch them into a single query? Does it do anything like that?
It's going to use this buffer that we call toWrite, where it's going to have a kind of a map of all the values that are changed for each record, and then it tries to optimize that as much as possible, to merge all the fields values in a single update, and possibly, if there are multiple records with the same values that are being assigned, it's going to do it with a single update. I don't know if that answers your question. It does it like that, but if there are like multiple values that are different and need to be updated on different records, then it will do a single query for each record, because it's not going to make a prepared statement, or if that was your question.
Basically, it's possible, for instance, if you have created like multiple records, you can batch those together into a single insert statement.
Oh, yes. Yes, that's how it works. Actually, it was already doing that in a change that we did over the framework of Odoo 12, where it was doing batch inserts and inserting several records in a single query. You're right. So it still does that.
Thanks.
I guess time is up, but maybe you, or if it's really quick, or you just ask me on.
I can ask you later.
Oh yeah, I'll be over there, and you can ask me any questions that you have. Thank you.
Hello, good afternoon. My name is Jordi Ballester. I'm from CEO of Efficient. Today I would like to talk about becoming demand-driven with DDMRP. DDMRP stands for Demand-Driven Material Requirements Planning. So in this presentation, I will introduce to you to what is DDMRP, what is demand-driven adaptive enterprises, what are they, why DDMRP, what is the objectives. So we'll talk about this methodology and some steps on what is DDMRP methodology about, then how to become demand-driven, and we'll end up with a presentation of DDMRP in Odoo. So demand-driven material requirements planning is a methodology for inventory and materials management. It's born as a natural evolution of MRP for the current environment, but it also takes concepts from Lean, Six Sigma, theory of constraints. It tries to decouple the forecast errors and order generations. It addresses the topic of material requirements planning, where typically the MRP fails because it tries to use data from forecasting. And this methodology was created by Carol Tuck and Chad Smith. They published this book, DDMRP. And I found this methodology when I was implementing manufacturing for a company in Denver, in Colorado, where after studying for a long time MRP, I realized that there was something else out there, and some people have thought about the problems of MRP and how to overcome these problems with a new approach. So as the demand-driven adaptive enterprise model is combining several aspects. One is the demand-driven operating model, which is kind of an engine where your company runs this engine at operational level. So it's the mechanics that drives what you should buy, when you should buy, and how to synchronize your purchase orders, your manufacturing orders, to make sure that you deliver successfully products to your customers. And out of this operating model, there is a more tactical tool that is called the demand-driven sales and operations planning that deals with the thinking of a company on how should I plan in the midterm in terms of my company, what I plan to sell, how do I want to deliver, think about capacity, and then figure out how I should set up my model to achieve some business objectives. And then there is a long-term vision, and that this is the adaptive SNOP that looks at the strategic side on the far future, where you have some business plan and you think about some future, and you need to translate your company. What is it going to take to bring my company from this state to some other future state? What should I set up in my business model and the operational model in order to achieve these objectives? The demand-driven adaptive enterprise operating model essentially is composed of a box that is the demand-driven MRP, DDMRP, that is essentially the supply order generation model. It takes information from the actual demand, but also from the model configuration parameters, and then defines when you should buy, when you should manufacture, and then it connects with other aspects, which is like the demand-driven execution, to make sure that what orders you generated are properly executed on time to ensure proper availability of materials at all times. And there is a demand-driven scheduling to make sure that materials and operations are properly synchronized. companies today, bigger and bigger companies are adopting demand-driven adaptive enterprise model like Coca-Cola, Moog Aerospace, Shell Lubricants. So this is becoming quite more and more popular, and it's a hot topic now in the manufacturing and warehouse management world. So why did MRP? In the 40 years ago, when the MRP was invented, we were under specific conditions. And these conditions in terms of supply chain complexity or product life cycles, customer tolerance times, product complexity, all these conditions were very different from what we face today. So now we have way more complex supply chains, longer product cycles, now are shorter. And so we are kind of in a different environment, but companies are still using the same principles of manufacturing, resource planning. And at some point, we need to think about investment. So from an inventory perspective, what companies do is we plan for to get some products on the market. According to some sales forecast, we start to buy or manufacture to try to achieve a certain objective. But reality, even when we make the best forecast possible, when reality hits, you realize that the market actual demand is different or the supplier response is different. You face delays from the suppliers, you face a different customer demand, and then you are in the situation where your inventory is such that you have too little of the right things and too much of the wrong stuff. So it's, what we see on the right-hand side is a typical MRP distribution, which is called a bimodal distribution. And we don't want that. We don't want to face shortages. We don't want to face excess inventory. So what should we do to try to have just the right amount of inventory for the products that we need to serve the actual demand that we have from customers? So you might be aware of the bullwhip effect. So the bullwhip effect is caused by when you do a small change in the customer demand, as you move these demands and create supply to your suppliers, supply orders, this typically generates more and more changes that are like becoming bigger and bigger. So there's a lot of distortion in the signal caused by small changes in the customer demand. And this is a typical effect. Okay, so from final product to as we see here, to the foundry, in every step, the signal is getting more and more distorted. And on the way back from the suppliers to the end customer, you also face typically more distortions on the signal in terms of product delays, and where a small delay in the supply chain becomes a huge delay in the final product. So this combination produces, as a result of this bullwhip effect, we face this bimodal distribution in the inventory. But we have to think, what is the primary objective of operations management? It should be to protect and promote the flow of information and materials. So we should be, as a company, we should try to promote the correct flow of materials across the company. We should try to avoid shortages, excess inventory, make sure that the products flow as quickly as possible through our company to the customers. So one of the ideas is we want to create independence between process or entities so that we noise or these changes in fluctuations from spreading throughout the supply chain. So this introduces the concept of buffers to try to decouple the parts. So the methodology of demand-driven is demand-driven MRP has 5 steps. So the first thing you should do, you should try to find where you want to put the coupling points, points of independence where you want to keep strategically inventory to ensure that the product flows correctly to the customers and you never run out of inventory on that product. But you should decide where you should put in your bill of materials, in your manufacturing, in your supply chain. So once you have decided where to put, you have to think here is of the placement criteria. So when things to consider should be like customer tolerance time, market potential lead time, there are some factors that guide you. This methodology provide you to decide where is best to put protection in your model. In this case, what we can see is a chart of a bill of materials. So where what you can see is to produce some end products and send to the customer, you see some routings and some assemblies. And some of the assemblies have some buffers, which you can see as 3-colored buffer. So these are points of protection where your company tries to make sure that there is enough inventory to satisfy any demand coming from upstream and protects these changes in the signal to spread throughout the supply chain or through the chain. So as you could see is in Odoo, you would see in your bill of materials how these buffers are positioned in the bill of materials. And so you can have a perspective of how you are protecting your bill of materials overall. So once you have decided where should I put buffers, you have to think, how should I size these buffers? And then you have to think about what are the correct levels that you should introduce to your buffers to be able to correctly protect the flow of materials. Depending, you have to think is what you have to think is a product that faces a lot of variability in terms of demand is likely to require more stock, more inventory on the buffer than a product that is really stable. And that is, you need to protect more products with some products with more stock in order to face the reality that sometimes customer orders change very frequently, and there is a lot of variability in terms of quantity or on timing. So you should analyze your signal and then decide how to size. The buffers are essentially sized and dynamically sized based on some critical parameters like the couple lead time and the average daily usage, and then some parameters which have to do with variability, lead time variability, or variability factor. So you can see here the buffer. The buffer is kind of a reordering rule on steroids. So it's providing you a specific view where you can see what are the key parameters that define the sizing of the buffer. And this is something you can check out in Odoo, and you can change. And will provide you the basic model configuration. Once you have defined the levels, profiles, and levels for your buffers, you have to think that this system is going to be responsive. So if you face more demand, the buffer will grow naturally because it's sized according to the daily usage that you face. Sometimes, though, the buffer will not be able to react on time. And because there is a sudden change in the pattern of the customer demand, might be. So sometimes you will need to anticipate to these special events. And this is where the dynamic adjustments can help with planned adjustment factors. Inside of the automatic adjustments is that the buffer will grow or shrink based on some parameters like the daily average daily usage. And the plan adjustments are parameters that you as a planner introduce into the model when you know that something is going to happen in the future. And typically that would be, for example, the seasonality factors where you know, or special events in the future where you know that there's going to be a change in the standard pattern, and you introduce some adjustment factors. So you say demand for November is going to be 5 times what is usual, because I know that in November we will have a special events, a special time. So the buffers will grow in naturally over time in order to be able to respond to during that time in November to actual demand. Demand-driven planning is the 4th element of the demand-driven operating model, or DDMRP, sorry. And essentially, it deals with the order generation. So in the DDMRP, when the buffer reaches a certain level in the net flow position, it essentially triggers a signal to the planner to order for more products. And this replenishment order could be either a purchase order or a manufacturing order or a transfer order. And this net flow position is the kind of the bar that dictates when this bar, the ordering moment, when this bar is below the green zone and reaches the yellow zone in the buffer, it's now the time to replenish. So the planner knows that he should now go and create a purchase order for this product or a manufacturing order. So this net flow position is calculated based on the on-hand position on stock on hand plus what's incoming, less what's the qualified demand. So it's an easy signal for the person on site in the warehouse to get to know when to reorder. And so reordering, as you can see, is not based on a forecast, is not based on, like in MRP, and based on what is the forecast and what do I need to order or buy based on a plan. Is based on the actual demand. That changes the net flow position and tells you when to reorder to basically replenish your buffer and continue to provide the protection that the buffer is offering, so that you can continue to sell to your customers according to some promised lead times, customer lead times. So you have in the planning screen in Odoo, you have a single dashboard where the planner can just check what's the current position of all the buffers and which ones do I need to take action on. The 5th component deals with visitable and collaborative execution. Essentially, once you have created your supply orders, this means I have initiated the process to purchase, to manufacture, but I need to follow up on those open orders. I need to make sure that the product will arrive on time in order to avoid stockouts. The situation is you're protecting, with your buffer, you are protecting your material flow through your company to the customer, but your duty is to protect the flow by constantly monitoring the status of those buffers. If you let those buffers empty because there is a bigger delay from the supplier or some disruption in the manufacturing, then you will face stockouts and you will degrade your service levels. But the good news is through a visibility on the status of the buffers, everyone in your company, like purchasing or manufacturing, can share the same information about the status of the buffers and can focus on the protection, can focus their thinking on the protection of the buffers. So naturally, the person in the manufacturing side will see a list of their manufacturing order, or a person in purchasing will see the list of their purchase orders, and they will be able to identify what's the status of the buffers that this PO, this manufacturing order, is protecting. So they can naturally then decide which are more important to prioritize, which POs, which manufacturing orders are more important than others, in order to properly protect the flow. So you would naturally try to prioritize first the orders that are that are more important to ensure availability of your buffers. Those should go first. And the orders where your buffer is in a good position then should go next, because they are not impacting on the flow. So the methodology provides different alerts, and like buffer status alerts, what's my status on my buffer in terms of the current on hand, the projected on hand, as well as synchronization alerts, where you decide not to put a buffer. You should know if a purchase order is going to affect potentially a manufacturing order that is connected to it. And so you should be aware that if I start this manufacturing order, I need a component that is not buffered. I have to make sure that the corresponding PO for the component, the purchase order, arrives on time. So there are synchronization alerts that help you to properly synchronize. So from the manufacturing app, you will see, as I showed you, I told you, for each manufacturing order, what's the status of protection of your buffers, so that you can prioritize properly these open manufacturing orders. From the purchasing perspective, there is a similar perspective. So how to become demand-driven? So the first thing companies should do is they should get themselves educated in the methodology. It's very important to go through the training, proper training. What we did in our case was we prepared for the Demand-Driven Planner program, which is a program offered by the Demand-Driven Institute. And we found it very complete. It provided all the education that was necessary for us to understand the key concepts. We loved so much that we became eventually instructors in this methodology. And now we will provide this education worldwide. So there is, this training can be provided on-site or online, and it's a 2-day training. And on the other side, companies will typically need, after they have education, they will need some software package to start getting on hands with this methodology. We created Efficient.io as a tool inside Odoo to support the DMRP, where we achieved the compliance from the Demand-Driven Institute, so that this tool really meets the requirements for this methodology. So let's have a look at DDMRP in Odoo. Essentially, this DDMRP is really embedded inside of Odoo. So it comes naturally as part of Odoo. So you will notice from the tool like embedded, like it's naturally embedded. So for example, from the bill of materials, you will see a product, a bill of material, you print the bill of material structure, and you can see where is a buffer. You can get to know all the information just right there, you will naturally find it in Odoo. So you will find also your stock buffers in inventory, where you can see your planning screen. You can get to know when to reorder, how much to reorder. So it's all the methodologies just embedded inside, fully integrated for a seamless experience. So thank you. If you have any question, I think time's left.
Well, hello. We are here to share our experience at the government of Uruguay with Odoo. We are from the Minister of Finance. We are going to show you how we use Odoo to improve our financial management. Our presentation has 5 steps. We organize this. First of all, we are going to share with you some figures where we are to understand the context of the process. Then we share the starting point. What was the situation when we start with this new process? And then we are to share with you also some figures of the GRPU, as we call our GRP based on Odoo, and the success and the challenge that we have to manage in this process, and how we see the future of our process. Where are we from? Many people ask me, where is Uruguay today? So this can be a little explain where we are. We are a little country in between 2 giants, almost for us. That's Argentina and Uruguay. And we are very little, but we have some particularities that can be difficult to understand. We have arrived to a good level of e-government. In fact, we are members of the D9, that is a collaborative network of the world's leading digital governments. We are there with United Kingdom, Korea, and Canada as an example. And how do we arrive to this? Our government has made a lot of efforts and developed a lot of projects to put us in a good situation in terms of e-government. First, the most area of that advance is sorry about my English, it's difficult to us, to achieve one infrastructure that can connect every agency of the government. We have a particular network, and every agency is communicated through that. Then the other advances are in the terms of delivery products and service to the citizen. And also because we are in the Minister of Finance, to collect taxes. That's a very good development that we have. But when I told you this, you will think that we have all the problems solved, and that's not true. We have very good development in collecting taxes, but on the other hand, when we talk about the result, we have to look at the expenses. And the expenses are responsibility for the agencies, and that we have not a good situation on that topic. So we wanted to improve that. And the first question that we asked is the government agency different from a private company? The first we thought is very different because of the goods and services that we delivered, the regulation system, and the human resource. But we look most closely the process that the government develops to deliver that goods and service. We can see that, in fact, makes the same process as the private sector. They buy
Goods and services.
Goods and services, thank you. They pay suppliers, they manage inventory, and so on. And that we arrive at the conclusion that an ERP developed for the private sector could, with some customizations, be helpful for us to improve the public sector. I said with some customization, but because we have the budget, and the budget has a very different role in the private and the public sector, and that's what is one of our customization. And also the procurement of the public supply. No.
The public procurement.
The public procurement, sorry. The public procurement that is very regulated in the public sector. What want to solve? What was the problem that we have? We are the Minister of Finance, so we are responsible for all the process, and we deal with financial items, with financial issues. And for that, we need the most information that we can, and the most detail of that financial information. Who has that kind of information? The agencies. The agencies that are responsible to produce and deliver goods and service. So, although we have a central system, as most of the countries, and if here is somebody from Latin America, we have very similar systems, we think that the only way to improve the management system is take another way, make another approach, and improve the agencies. Give them some financial system, integrated system that could be useful for them. And then, as a consequence, if the system is useful there, we are going to have better information at the central level. At this stage, I told you that we decided to use a private system, develop a private system, and we have to confirm if this strategy is aligned with the digital agenda of our country. And when we look at this, you can see there's one pillar is government management. So, aligned with the digital agenda, with good infrastructure to put on production one system, we decided to use it, and we decided to use the strategy for this one. These are the main goals that we want to achieve. We want to have better decisions based on evidence. And we know to have a system that can do that the agencies appropriate the knowledge that were in the organization, the knowledge that people have, but not the institution. And we think that using technology that will be possible. The next step was, to select the product. And that was an important thing that our suppliers help us. In the first two projects that we have, the institution select Odoo as the better product that the suppliers offer. And it was a product that was aligned with the one guide of our government is using open source. Now, this is the situation. In one hand, we have at the central government the usual systems that we have, integrated financial information, government procurement, contracting. On the other hand, at the agencies, we have the GRPUI with the process that the typical process, planning, finance, stock, accounting, that the private sector has, but two very important customizations, public procurement and budget. And in the middle, in between that, we have an interoperability platform that communicate both in the way that everyone has the level of information that they need and at the moment that they need. I can show you here the models of our GRP. Most of them, you can use it in the private sector, but here and at the first one, because we belong to the office, the budget office, is the budget. And one is in another color because we are trying to, we're now developing this model is cost accounting. What happens there? Well, our two first projects were very successful, and a lot of agencies raised their hands and said, we want that system. We want to share with you the process. We want to share with you our knowledge. And that means that we have a lot of projects at the same time. That's a huge challenge for us. But at the same time, it means that we are on the right road. I told you this in very few minutes, but that picture shows you that it was a huge effort. We have more than 80,000 civil servants to use the system, more than 10,000 hours of work, and a lot of teams working on that. Also, at the end, or now, we have a product, we have a challenge, and we have a lot of problems. Really, when we start the process, we didn't believe that we will arrive at this stage. The main problem that we have is to manage the product and to manage two aspects of the product. First of all, the technical evolution. There's a huge challenge for us. Fortunately, we have a lot of people working on the same product. Odoo company, the first, the OCA, and a lot of people in Uruguay, even if they are not in the program that we are working on, they are working on the evolution. Now, we have the product in version 8, and that's, I would explain why. The times in government are very short. One government is 5 years at the government, and we have to show results very quickly. There were two projects that started to use Odoo, and we decided to use that experience to base our product on that experience to show results very quickly, to show to the government that this is the way that we have to do. The other process that we are responsible for is a functional evolution. And the most challenges that we have is that every user wants to have better functionalities or solution for something now. And we have to align the times of the evolution, functional evolution with the technical evolution. How we are trying to manage that will be the responsible Marcela for tell you.
Hello, everybody. I have to confess that we didn't know that we are going to speak in this big space, and I'm a little nervous. I feel like a rock star, but without a star. Well, as Marta mentioned it before, we started with 2 projects, one in the Ministry of Labor and other in the Ministry of Health. And we decided to synchronize these 2 projects in order to share experience and, to be honest, to reduce costs. Both projects were executed at the same time, sharing information and knowledge between the teams, and most important, sharing the customization that we designed to be useful for both agencies. At this point, we started to think in to develop a single product suitable for all public agencies. Most of the functionalities developed from the Odoo standard functionalities. And we organized this idea as a product with different layers. As you can see, the GRPUI, as we call, the product that we have developed, has 4 layers. The first one is the Odoo layer itself that contains all the standard functionalities of Odoo. The second layer is the Uruguayan localization layer. The third layer is the government layer that contains or implements all the common government processes, and this is the layer that implements the GRP. And the last one is that is the 4th layer. It's a specific layer with functionalities that are specific for each ministry, and they are not applicable for other agencies. Related with this layer, at the beginning we thought that this was really necessary, but we quickly changed our mind because when we saw that the 99% of the functionalities were shared by all the agencies. So we also changed our mind in terms of the implementation strategy, and we designed a new methodology that we named GRP Express. And to explain you the impact of this change, I have to say that the first project took around 14 months, and the last 3 projects that we had implemented only took 4 months. And if you know something about projects and time in government, particularly in Uruguayan government, you can agree with me that develop an entire GRP for the public sector in just 4 months, it's a record time. In the slide, it's just to see, to explain yourself, how the different layers are organized. You can see the different modules of our GRP and how it are extended from the Odoo standard functionalities. And to explain better how all the process went, I have told you how the first idea was born, but immediately we had to deal with a big problem that we had a product, and without experience in how to deal with it. So one of the first actions that was taken to help us in the management of the product was promote the creation of a community around the GRP with different users, suppliers, and developers that help us with the management of the product. And currently, we have different public agencies and people from different parts of the public sector working with us in different activities, as, for example, identifying new requirements, designing new functionalities, and even testing new versions. Have a community as we have, it has many benefits, but one of the most important benefits, I think, is an economy of scale, that I have mentioned before to reduce the cost of the new projects. The first one took 14 months, and today only took 4 months and a quarter of the price of the first one. So this is also a big issue for, this is very important for us because we are the Ministry of Finance. Here you can see some key actors and key activities related with the governance of the GRP, GRP Uruguay. One of them as a functional committee that decide the priorities of the different the new functionalities, and decide also how and when this functionality are developed and delivered. One of the key actors of this ecosystem is Odoo company, because every year deliver a new version, and in spite of this is a big good news for us because someone is caring about the improvement of the baseline of our product. Also, it's a challenge because we have to synchronize the functional evolution of the GRP UI and the technical evolution of Odoo. And this is not a simple task because when we started, as Marta mentioned it, we had a quick growth in the number of projects that we had to manage, and the evolution of the product was not the most orderly. So a technical debt with the product produced a technical debt with the best practices in software development. From then to now, we have tried to organize all these activities. We have created product management office and try to centralize some of the activities to trying to improve the quality, the technical quality of the product. Today, we are working in the third step, and the whole idea of this step is to change the development scheme based on continuous integration and continuous delivery using OpenShift as tool, and with the whole purpose to ensure the quality of the entire development and delivery cycle. One of the challenges that we have to deal with in the third step, yeah, I know, is that we have to move to migrate our baseline from product from version 8 to version 12, and for this purpose, we today have published a call for expression of interest in consulting services to implement the migration project, and we plan have the GRP UI or GRP Uruguay upgraded by the end of 2021. And we have no more time, so it's all that we have to share with you. And any question, we are going there for you. Thank you.
Thank you. Me quedaron 8 minutos.